Thank you for joining us and welcome to Innovation on the Edge, an SKF technical webinar focused on delivering greater efficiency and high performance in data center applications. Over the next hour, we're going to show you SKF technologies and solutions that are engineered to overcome data center challenges. High thermal loads, variable speeds, poor lubrication conditions, and the relentless demand for uptime and efficiency with operators under constant pressure to improve power usage effectiveness. Well, we understand the challenges and we understand the fast pace at which you're working. It's why SKF has made significant investments, allowing us to deliver the products you need when you need them. We've established vertically integrated supply chains for SKF Hybrid Ceramic and Magnetic Bearings. That means we're ready to adapt to your needs and are flexible in our ability to prototype and customize designs. It allows us to reduce lead times and meet your demands. Well, data centers are among the fastest growing energy consumers worldwide. SKF's focus on sustainability, powered by enabling technologies, directly addresses this challenge. To tell us more, here's SKF's Chief Technology Officer, Annika Olme.
The world can't afford friction, so let's scale what works. For the data center industry, this means understanding something important. Sustainability, efficiency, competitiveness, and operational resilience are all interconnected. They are not competing goals. They all work together. So that means that we have to collectively remove systemic friction, such as outdated mindsets or conventional operational practices, to scale proven, sustainable products and solutions together. As Chief Technology Officer at SKF, my focus is on the future. That future is clearly digital. It's powered entirely by what you do every day in your data centers. But that future also has to be sustainable. We all know that a future without data centers is impossible. We have to get serious about making them more sustainable at every stage of their life, from cooling systems to critical infrastructure around the data centers. The challenge is clear for all of us. How do we support massive digital growth in the world without compromising our planet? And today, I'm going to share SKF's focus on sustainability and our customer-centric approach on innovation that supports and benefits data center operations. First, I would like to start with what is SKF? We have been friction fighters for more than a century. Today we serve more than 40 industries with products, services and engineering solutions that enable progress and contribute to a better everyday life around the world. Our strategy is based on two parts: intelligent and clean. These two parts guide us on our journey to become an even more focused, innovative and profitable industrial player. So intelligence really means providing connected and tailored offerings for our customers, but it also means using technology to make our own operations more efficient. Clean reflects our ability to enable a more sustainable industry, while running our own business in a transparent and responsible manner. Sustainability is not a new concept for SKF. It is really how we operate in our DNA every day. And we focus our efforts on three main pillars. The first one is climate transformation. This is all about how we run things, and we are committed to achieving net zero in our own operations, in our facilities, in our supply chain, but we don't stop there. We want to lead the charge in helping the entire industry to get to net zero by providing clean tech solutions that reduce friction, save energy, and cut carbon emissions. The second pillar is circularity. This one is all about being smarter with resources and materials and moving away from this take, make, waste model into more circular models across the entire value chain and supply chain. Now, this starts with how we design our products. It goes through how we operate and how we manufacture our products. It also covers the entire product life cycle, all the way to customers, from where you use it to when it reaches the end of life. And we're moving towards circular business models for SKF, for you, and for the whole value chain to reuse and recycle. The third pillar is responsible business. Very simply put, this is about doing the right thing for people and for the planet. We ensure that we conduct business in the right way, all the way from our own operations to every single business partner we work with. And we see our role in society as being a force for good and actively advancing a better tomorrow through how we operate. So we have committed to specific goals. The Paris Agreement goals we are supporting, and we want to be a part of keeping the global temperature increase below 1.5 degrees C. To do that, we have ambitious targets of our own. The first one is decarbonized operations by 2030. That includes all production facilities all over the world. We also have net zero green gas emissions in the value chain by 2050 as a full value chain net zero by that year. And our net zero targets have been validated by Science Based Targets Initiative, SBTi. Now, as a society, we all need to move towards a clean net zero, fully circular economy. And we need to do that faster than ever before. And our biggest role in that is working with you. We design our products to be lighter, more efficient, longer lasting, and easily repairable and reusable. Our products help reduce friction in critical rotating components, such as fans or cooling pumps. That's how we can help you achieve energy and carbon savings, while still handling the massive growth that you stand in front of. We also help enabling clean technologies within industries such as wind, tidal, and so on. And we can partner with you to ensure that your data center operates with the maximum efficiency and the minimal footprint. We can also extend the life cycle of critical assets. SKF Remanufacturing offers a faster, lower carbon alternative to replacing bearings and instead reusing bearings over and over again, boosting asset longevity and reducing CapEx and OpEx. We have a transparent path to net zero where you can partner with us to decarbonize your own supply chain in Scope 3. So, as you can see, we're always challenging ourselves and others to find new ways to make sustainable business the only business. So, let's talk about how we enable data centers to become more sustainable. So we know that modern society cannot function without data centers. It's key. But you also have a dual challenge, ensuring massive and non-stop uptime in data centers, but still meeting increasingly strict sustainability mandates from customers, investors, and regulators. Data centers consume roughly 1.3% of the world's electricity. That is a number that is climbing dramatically. For every kilowatt hour that you spend, that you save, it translates directly into improved profitability, but also to a lower carbon footprint. Every rotation in your pumps, in your cooling towers, in your HVAC systems is consuming energy. And our goal at SKF is to help you systematically shrink that footprint and turn these challenges into competitive advantage. So where do we start? It's a focus journey. And let's look at 3 areas where we can really start to do things together. The first one is about choosing efficiency, low friction products. The second one is about optimizing uptime in condition monitoring and digital services. And the third one is about embracing circularity through remanufacturing of bearings, but also oil reuse. Let's dive into high-efficiency cooling. Now, data centers require extensive cooling systems and power distribution equipment to function, and all of these systems rely on bearings. The need for energy-efficient cooling in data centers creates a demand for components like magnetic bearings, which are more efficient than traditional ones. They actually have 0 friction. And as data centers focus on sustainability and reducing energy consumption, there's a demand for bearings that offer lower friction, such as low-friction hub units and specialized seals and greases for cooling equipment as well. When it comes to optimizing uptime, it's a high-stakes environment in data centers, and that means we have to minimize downtime in your operations. Our condition monitoring technologies for predictive maintenance monitors that bearing health and prevents failures before they occur. Embracing circularity means that as data centers are upgraded or decommissioned, there's opportunities to actually refurbish and reuse components. Remanufacturing offers a way for data centers to participate in the circular economy. Why discard a bearing when you can restore it to like new and use it again? Our remanufacturing program extends the service life of bearings. It cuts costs. It reduces environmental impact of new bearing production as well. And our patented recond oil technology makes sure that you can extend the life of cooling systems by reusing oil instead of replacing it. It improves machine performance, it reduces cost, and it reduces environmental impact as well. So the path forward is clear and actionable through those three areas. To achieve this kind of operational and sustainability shift, we all need a partner, a partner who's constantly pushing technology boundaries, and that's where SKF's innovation history comes in. For more than 120 years, we've innovated based on what customers need us to do. And we're continually investing in technology development to meet both your current demands, but also the future needs of the digital world. Our internal innovation teams, backed by external open innovation as well as academic partnerships and SKF Ventures, are laser focused on overcoming the next challenge that you will face in the data center world. This ensures that we can deliver smarter, more sustainable solutions for you in your most critical assets. But we don't innovate in a vacuum. To move fast and to deliver the right solutions, our innovation efforts are organized around 26 core technology areas where we are the leader. And we work on these alongside with our customers and partners. We focus on AI for practical, scalable solutions, treating high-quality data as the foundation for superior decision-making for you and for us. We're also investing heavily in digital twins, new low-friction materials, and monitoring emerging technologies that come across so that we don't miss something. And it's all designed to secure reliable, highly efficient performance today and in the future. In this way, we can ensure that our customers, and in this case specifically data centers, can unlock a range of advantages, all the way from reduced operational cost to lower environmental impact. We are ready to be your essential partner in this transformation. SKF innovative products and solutions are developed for meeting and exceeding your most ambitious efficiency and CO2 reduction targets. We bring proven technology and expertise in high temperature, low lubrication environments. We offer advanced bearings like hybrids or magnetics and intelligent solutions for condition monitoring for your critical infrastructure needs. There's a full suite of offerings that is built to dramatically reduce your own total cost of ownership while improving reliability. So let's fight friction together, creating a digital world that is smarter, more sustainable, and fully reliable. Thank you.
If you're here with us, you're working to innovate in your field. You're pushing the technological and operational limits of your data center applications. SKF is the right partner for you because we're innovators too, and we're comfortable pushing limits. Our bearings have been on the moon and on Mars. They're found underwater in machines that harness ocean currents to generate electricity. And on dry land, SKF pushes the speed limit with Scuderia Ferrari as a technical partner since 1947, the longest-running technical partnership in Formula One history. SKF Advanced Technologies are performance enablers, like hybrid ceramic bearings, engineered to work in the toughest of conditions. With a deeper look into hybrid ceramics, we'll bring in SKF Senior Engineer in Ball Bearings, Rudi Hallleitner.
Thank you, Jeff. My name is Rudi Hallleitner. I'm Senior Engineer in Product Development for SKF, and I'm excited to talk to you today about the benefits that hybrid ceramic bearings can bring to your data center applications. Let's just jump right into the presentation. So hybrid ceramic bearings, as you probably know, are bearings where the rolling element consists of ceramics, in our case, silicon nitride. And these ceramics are actually highly technical ceramics designed for the challenging conditions in the rolling element contact. Also, what is important to mention talking about hybrid ceramic bearings is that this is an internal design feature. So your boundary dimensions of these bearings are completely the same as that of a standard bearing. So that ensures easy interchangeable with those bearings that you might have already designed in your application. Let's have a look why this rolling element material actually matters so much. Silicon nitride is significantly lighter and also stiffer than a steel rolling element, but this is by far not all why you benefit from this material in your application. To understand the full advantage of hybrid ceramic bearings, we must look into the contact of the bearing, because that is really what determines the capabilities and the robustness of a bearing. This is a very small area where the rolling element material is separated from the ring, which is exposed to very high temperatures, high pressures, and the material pairing really plays an important role there. So silicon nitride is significantly harder than steel, which helps you to ensure a superior performance in contaminated conditions or to reduce wear, for example. Also, the surface finish of silicon nitride is very smooth, which gives you an advantage there. And last but not least, the interaction between two different material together with the lubricant really gives a huge benefit. It lowers the friction in this contact and it makes the bearing just more robust to harsh conditions. Ultimately, this results in an increased bearing life, especially under these harsh conditions. On the next slide, we see a brief overview of those advantages of hybrid ceramic bearings. But I actually don't want to go into all the details now, just to point out a few of them. Hybrid ceramic bearings help us to eliminate the risk of electric current going through the bearing, like for example in electric motors, and completely prevent the damage from these electric currents. Also, the speed capability due to the lower weight and the improved tribology in the contact is significantly increased. Then the high stiffness leads to a higher rigidity of the bearing and allowing for improved precision of the bearing. All this improved tribology leads to an extended service life, especially under these harsh conditions. And we have also developed a generalized bearing life model, which is capable of quantifying this benefit and representing this, especially for these hybrid ceramic bearings. Last but not least, if you combine this benefit of an increased life, an improved performance of the lubricant in combination with this material and the robustness, we see a strong benefit in the sustainability that this solution can bring to applications. On this slide, I want to show you some of the industries that already successfully adopted hybrid ceramic bearings in their applications. So early adopters generally were really looking for a problem solver, and they implemented hybrid ceramic bearings specifically for one of their premium features. So it might be the elimination of electric currents, like in electric motors, or in other cases, it might be the improved speed capability, like in racing applications or machine tool applications. But later implementation in the industries, they actually tried to capture the full portfolio of the benefits that hybrid ceramic bearings offer and see it more as a game changer to explore new territory on the operating map. And what I have experienced from industry is that whenever they started to adopt hybrid ceramic bearings, they really stick to them because they knew maybe about some benefits that helped them right away to solve a problem, but later on using them, they just discovered the full potential that they offer to leveraging their application. Now let's look specifically into the data center application and the challenges that rolling bearings are facing there. In this application, we are looking at pumps, electric motors, compressors operating in these facilities, and they are facing higher temperatures, a wide range of speeds from variable speed drives, for example, challenging loads that come maybe from downsizing or the application itself, a lubrication that is often compromised by mixture with refrigerants, contamination, or the risk of electric current damage. So you see already that this is a very good fit to the advantages that hybrid ceramic bearing offers. And actually, what we try to do is we try to turn these challenges into a new opportunity by implementing hybrid ceramic bearings and explore how we can make these machines more efficient, smarter, and more reliable with this technology. Let me jump into one specific example where I have worked on quite extensively. And this is an oil-injected screw compressor lubricated by the mixture of an oil and a refrigerant. Traditionally, these machines were used in air conditioning units like large chillers, but the same technology is also adopted in heat pumps or in the cooling for data centers. The lubrication of these the bearings in these screw compressors is really key for the success of this machine. And as you can see in the diagram on the right hand side, it gives you an illustration of how this lubrication quality varies in different areas of the operating map based on speed and temperature, but also depending on the use of the refrigerant and the oil and how the oil is diluted by this refrigerant. This should just give you an indication that we have the tools to really understand and compute the conditions that these bearings are facing, and that helps us to give you really the right offer what will perform best in your application. Let's have a look how the lubrication quality or also the viscosity are affected by this mixture of oil and refrigerant. In this diagram, you can see on the left-hand side the viscosity of the pure oil, which is maybe in the range of 100 centistokes. And on the very right-hand side, you can see the viscosity of a pure refrigerant, which is close to 1 or similar to the viscosity of water. But this transition from a pure oil to a pure refrigerant is not linear. So your viscosity actually will drop much faster than the percentage of increase of dilution in your application. And traditionally here we were facing maybe dilution values of 10 to 20% in air conditioning applications. But now moving to higher temperatures and also due to the introduction of new refrigerants, we are facing values of dilution going up to 30% or even beyond. And that really drastically reduces the lubrication quality and actually exceeds the capabilities of an all steel bearing. Nevertheless, for a hybrid ceramic bearing, this is really one of its core strengths to operate in these conditions. And one of the applications that really showed us those extreme benefits that hybrid bearings offer is the application of pure refrigerant lubrication, abbreviated by PRL, where we actually are capable of lubricating a rolling element bearing using ceramic rolling elements with a pure refrigerant. So that is all the way on the right-hand side of that graph, while still maintaining a high level of robustness. Let me summarize the presentation and why I believe SKF Hybrid Ceramic Bearings are the right solution for your application. SKF is not only the manufacturer of a bearing, but we also have heavily invested in the complete value chain from the production of the powder, the manufacturing of the rolling element, all the way to a deep understanding of the application. And I think that all these areas benefit from each other. So when you are aware of the challenges that the bearing is facing in the application, it also helps you to define how you have to manufacture the powder and how you have to machine and manufacture that rolling element in that bearing. And SKF is just operating across this full value chain. Last but not least, I would really like to emphasize that a hybrid ceramic bearing is not just a bearing where the rolling element material was exchanged, but that actually it is a game changer in the way it operates and how it is improving its performance in especially harsh conditions. And I would really emphasize that together with this technology, we are capable to explore new operating areas for your machines and excel the performance in your application. With this, I want to thank you for your time, and please feel free to contact us if you have any questions how we can support you with hybrid ceramic bearings, and I hand it back to Jeff.
Rudy, thanks. Our engineers are problem solvers, and they want to hear from you. What challenges are you facing? Where do you see opportunities to innovate? Let's explore those together. Send us your questions via the Q&A tool in this webinar, or scan the QR code for more SKF information and a link to reach out to us. Our team is ready to start the conversation and collaborate on solutions. Up next, a solution that doesn't fight friction. Instead, it operates with no friction at all. SKF Magnetic Bearings. Let's learn more with our sales manager of magnetic systems, Mark Hinckley.
Hi, Jeff. Thanks for having me. My name is Mark Hinckley. I'm the Director of Sales for SKF Magnetic here in North America. And today, I'm going to talk about one of the most innovative and game-changing technologies that SKF has to offer. This is a technology that, when used to its fullest capability, it can enhance the performance and add intelligence to your equipment. Yes, I'm talking about SKF high-speed motors that are equipped with our magnetic bearings. We're going to cover a couple of key areas, and I want to introduce you to the technology, and then to understand how it helps to fulfill the demands of today's data centers. So, managing heat that's generated by a data center is absolutely critical. The cooling systems that do this must be reliable and energy efficient. So, projections show that worldwide data center demand for energy are projected to double by 2030. So that means approximately 945 terawatt hours of demand will be required. And that's enough power to supply 70% of all US homes for a year. Or another way to look at it, it is approximately the annual electrical consumption of a large country like Japan. And with 30 to 40% of a data center's energy consumption going to the cooling systems, it's absolutely imperative that these systems be as energy efficient as possible. This is where SKF's high-speed motors with magnetic bearings really shine. They are specifically designed for use in centrifugal compressors for both air and water-cooled chillers. A chiller equipped with this technology will have the highest levels of performance, and they are engineered to enhance operational reliability, reduce maintenance requirements, and improve overall energy efficiency. So as we go through the next few slides, I want to show you that why when you use these chillers with this amazing SKF technology, you will have less downtime. You will have class-leading energy efficiency, and you will have minimal maintenance requirements. I want to talk to you a little bit about some of the basics. What is it about magnetic bearings that make them such a good choice for centrifugal compressors? The first key point is there is no contact when rotating the shaft inside the compressor. The shaft is levitated using electromagnets. This levitation then opens up a host of other benefits. There is no oil. If there's no contact, then there's nothing to lubricate. So get rid of the lubrication system and all the maintenance that goes with it. There is no wear. Again, without contact, surfaces don't touch each other, so they do not wear over time. And one of the best, there's low vibration and low noise. This is due to the active position control of this magnetic bearing system. The vibrations and noise are dramatically reduced when compared to traditional technology. Chillers that are equipped with magnetic bearings have been shown to be on average 12 decibels lower in noise level. It's really amazing. And the lack of friction also unlocks the high-speed capability of the SKF motor. And this friction-free, high-speed operation is more energy efficient than other technologies in the market. By now, you've got to be wondering how. How do they do it? Well, let me tell you. So a magnetic bearing system is made up of a few key elements. We've got electromagnets, we've got a rotor, we've got position sensors, and we have a controller. There are some other mechanical parts thrown in there as well, but these are the key aspects, the key elements of this system. In its simplest form, the electromagnets are like the ones that you made when you were a kid. You wrapped copper wire around a nail and connected it to a battery to try to pick up the heaviest piece of metal that you could, right? At SKF, we've just spent a little time and effort engineering them to do exactly what we want in a centrifugal compressor. So what you see on this small animation in the upper right corner is how the different elements interact with each other to control that rotor position. When the rotor moves away from center, let's say by gravity, pulls it down, the position sensors register that change, right? They send this detail to the magnetic bearing controller. This controller is receiving data from this sensor at about 20,000 signals per second. So it knows very, very well just what's happening to the position of that rotor. With that information, it can determine how much power to apply to the electromagnets. And as that power is applied, it pulls that rotor back into position. And they repeat this process over and over, controlling the orbit of that rotor as this machine operates. Now, let's think about it. The interesting part really happens when something that's unexpected occurs, right? This could be a number of things like surge entering the system or maybe a contamination, right? I like to use the analogy of a juggler. If you have a juggler who is juggling bowling pins, he's using his eyes as the sensors. His hands and muscles are the electromagnets, and the pins are the rotor. So the juggler is continuously monitoring the orbit of each pin and can juggle those pins without issue. But what happens when someone throws in a bowling ball, right? The juggler sees the ball coming, and he knows that he needs to apply more force to juggle that ball, but he also understands that the pins do not need this extra force. So he applies it only when the ball is coming around, but immediately adjusts the force to continue juggling the bowling pins at the same time. This conceptually is what happens thousands of times per second in a magnetic bearing system. The sensors are feeding data constantly to the controller, and it is adjusting exactly the right amount when and where it is needed. So, as you can imagine, there is a lot of data within this magnetic bearing system. It starts as simple position data, but there is a lot of it. That simple position data can get you a lot of information regarding how that machine is running, if you know how to listen. SKF software suite is called MV Scope. It's designed to allow you to listen to what your machine is telling you. through snapshots. If you want to know, when was that bowling ball first introduced to the juggler? This is going to let you know. The next one, an event viewer. You want to know the details regarding how much force was required to compensate for that bowling ball. How frequently did that happen? Was it one bowling ball or two? You're going to be able to tell just from this event viewer. You've got trending. Do I have the same number of bowling balls today that I had a week ago? What about a year ago? Is there a trend? Are they increasing or decreasing? Orbits. What does that control look like? How high does the juggler throw the bowling ball? What about the bowling pins? How is that affected by the introduction of this disruption of that bowling ball into the system? And then a 3D waterfall lets you visualize any number of these points of data through time and frequency. So it really, really is a powerful tool to get a higher level of understanding of how your machine is operating and what you might want to do to optimize its performance. So next, I wanted to talk to you just about why does this make magnetic bearings such a good fit for data center applications? The chiller that utilizes SKF magnetic bearings, it's not only more efficient than the other technology on the market, but the chillers themselves are able to be designed in a very compact and more efficient way. Without oil lubrication systems and the associated maintenance that goes with them, the chiller itself is greatly simplified. And like that juggler, these systems with SKF magnetic bearings are flexible and versatile to handle a wide variety of situations, ready for whatever is thrown at them. But we have talked about a number of the benefits that SKF high-speed motors and mag bearings can deliver. But what does it really mean? It means uptime. It means more uptime. Uptime is king. You will save money and get a more reliable system that is always ready to go. Not just the energy savings, but because there are no complex oil systems to manage, that mag bearing chiller can be ready to restart in just a couple minutes after an interruption in power. And don't forget about those advanced monitoring capabilities. The data and trending capabilities inherent in these systems really offer them a big advantage over traditional solutions and make them very hard to beat. Just to wrap up, we have talked about why is it so important to have the most energy efficient and reliable solutions possible for data centers. We've talked about the benefits that magnetic bearings bring and how they deliver them. We've talked about what possibilities exist to upskill your operations with advanced data analytics that are available from these systems. And finally, what it really means for your data center. More uptime. Chillers with SKF high-speed motor and magnetic bearing technology are the choice for data center cooling. They are the most efficient, the quietest, and the most reliable. They are the best solution for your cooling needs. Thank you for spending your time with me today. I am looking forward to continuing our conversation about SKF high-speed motors with magnetic bearings. Jeff?
Mark, thanks. Turning now to a technology that can give you a deep look into the performance of your bearings, a fiber optic solution we call SKF Insight. It's a product that's perfect for data center applications as you strive to understand technical limits and push beyond them. Let's learn more with SKF's Global Product Manager for Intelligent Bearings, Mark Verbakel.
Hey, hello everyone. My name is Mark Verbakel. I'm the Global Product Manager for the SKF Insight sensor bearing solution. It's really a pleasure for me today to be part of this webinar and for me to introduce you to our new product and how it could support your ambitions. So let's get started with some context. Data centers are growing, let's say, very, very fast, and they are pushing performance. Now, of course, they want to push the performance with confidence. Nobody, let's say, likes unplanned downtime. But let's look on the left here where we have the challenging demands. 20%, some sources say, is the annual growth of the cooling market to 2030. That's very big. Yeah. AI, of course, as a key driver for that growth. Now, reliability, as mentioned, is super important for these data centers. We don't want any unplanned downtime. We want these machines to be available. And then on top of this growth and reliability, we also want these machines to be very efficient in their operation. We don't want any lost energy, because for obvious reasons. Now, in these data centers, in a typical data center, you will find quite a number of critical bearing positions. Think of bearings in cooling pumps, in air pumps, in cooling chillers, in fans. So there's quite a number of places where bearings are critical to the performance. And what we are offering is insight into those critical bearing positions, deep insights. Yeah? First of all, we want to provide these insights for you to push the performance of the data center. And we do that by providing you with the actual bearing conditions. And I'll come back later to what we mean by that. We will provide with this technology to you data and facts. So detailed bearing health checks, no guesswork, no assumptions, but actual data that confirms that the bearing and the machine is in a good condition. And lastly, it is our ambition to increase the efficiency of these machines, of screws, for instance, screw compressors, by making it possible to run with smaller clearances, because we are monitoring if the rotor is contacting the housing. Yeah, so this way we can avoid problems before they escalate. Now, next I would like to show you more about the product. We call them SKF Insight sensor bearings, and they are powered by fiber optic sensing. Now, this allows us to measure from deep within the machine, deep inside the machine from the bearing. And this bearing will provide you with real-time data on the loads acting on the bearings and the machine, on the temperatures at which the bearing is running, the cage speed, which is an important indicator of the condition. And it also provides you with vibrations from inside the machine. And all of this in the same bearing package as a normal bearing. So we're not requiring any additional space. In the center of this slide, you see the working principle. As mentioned, it's based on fiber optic sensing. This is very much equivalent to electronic strain gauges, but then using light instead of electrons. Now, how this works is through what is called fiber Bragg gratings. You can see them in the animation below in the slide. And these fiber Bragg gratings, they act like tiny mirrors. So instead of sending electricity, what we do is we send in light into the fiber, and these FBGs, they reflect a little bit of the light back. Now, all of the information on the loads, the temperatures, the speed, etc., it's all contained within these reflections. Now, the beauty of the technology is that we can put many of these FBGs in just one fiber. So one single fiber can accommodate many sensors. That allows us to be super compact in this solution. And that is why we can stick to the same size bearing. And just to illustrate how compact this technology is, I want to show you what it would look like when equipped with electronics. Yeah, so and this photo that you see here with all the wires, this is not even half the amount of sensors that the one on the top, equipped with fiber optic sensing, is capable of providing. Yeah, so as you can see, for us, fiber optic sensing is really a game changer and allows us to bring all these benefits to an industrial use case. Now, next, I would like to show you the different components of the full system. The key components. It starts, of course, on the left, and we go to the right. On the left, we have the bearings, and it can be multiple bearings, as many bearings as needed, that can be connected. And they are connected and put together in a junction box that is most likely near to the machine. We try to keep it close to the machine so that the fiber length from the bearings are kept at a minimum length. Yeah. Then from the junction box goes a transport cable, and this transport cable can then be any length. Literally, it can be miles without any loss of signal. The fiber optics guarantees that there's no loss of signals for miles. The transport cable ultimately connects to a device, the black box that you see there on the right. This black box, it is both the light source, so it is the device that sends in the light into the fiber, and it also analyzes the reflections coming back from the bearing and its sensors. Also in this black box is computing power. We need computing power because all those reflections need to be converted into actionable data, the loads, the temperatures, vibrations, etc. And these data streams are output, let's say the black box outputs these data streams to a platform of your choice. So it really depends on your situation, what's convenient for you, and we will accommodate to that setup. What's important for you to realize is that we are outputting these data in a universal format like OPC UA and MQTT protocols. So we try to make it easy for you to use your data platform. That's our philosophy. So by now you might wonder, well, where is SKF with this technology? Because we started working on this already back in 2008, and we had the first successful implementation in the field in 2009. And you can see here on this slide a few examples of these applications, ranging from marine to compressors, mining, and machining spindles. And in each of those, we are realizing interesting results. Most relevant, of course, for data centers out of these four would be the compressors. And so let's look into the results that we have generated in the compressor field next. So here we are, SKF Insight sensor bearings turning, let's say, a compressor or a pump into a self-monitoring system. Starting from the left, we see their loads and temperatures generated by a bearing in a screw compressor. And what you can see in the loads, in the blue polar plot there, you see the 4 lobes. Those are indeed the 4 lobes of a screw compressor. So every time the lobe passes the exit, there is a puff of air, and the bearing actually senses this puff of air 4 times per revolution. Hence, we have this graph with 4 lobes. Next to it, right next to it, you see almost a circle, circular axial load, but it has an offset, and this is say coming from an unbalance. So it's a way to detect unbalance in the system. Then we have the temperatures, and the temperature is not measured just at one point, like is often done with a thermocouple. Now, in this case, we are measuring the temperature inside the bearing, very close to the raceway, at multiple points. So this allows us to monitor the temperature gradients inside the bearing and detect any problems, let's say, early on. In the middle, you see a vibration intensity plot. In this case, the compressor is going through a speed ramp up. from the bottom going to the top with increasing speed. And you can see a number of sharp lines. You can also see some vertical bands. Those vertical bands are machine eigenfrequencies. And the, let's say, angled lines are typical frequencies, like the bearing frequencies or the 1-time shaft speed, 4-time shaft speed. Now, there's a lot of detail in this, but what's really the message here is that we can really generate a crystal clear picture of what's going on with the machine, much more clear than with our conventional condition monitoring equipment that utilizes a vibration sensor on the outside of the housing. Yeah, we are inside the machine, and this picture is compiled from multiple sensing points inside the bearing. So that generates a very, very high signal to noise ratio. And that is the starting point for a detailed diagnostic. Yeah, that can be done periodically or when suspecting some troubles or on a continuous basis. Yeah, so it's an excellent way to make sure that the critical asset is running in a good condition. Now, on the far right is another implementation of how to use this data. If you know the historical loads and temperatures of the bearing, you can actually use this data to make an update on the predicted life of the bearing. Now, there's always a statistic around it. We never know exactly what's ahead of us. But this data gives us the best possibility, the best starting point for a robust, updated statistical life assessment. All of this, of course, to avoid unplanned downtime. Now we're slowly coming to the end of this part of the webinar, of this presentation, and I would like next to highlight the key advantages of our sensor bearing solution. Starting with number one, we are providing actual operating conditions, not estimates, not guesses, not simulations, no, actually measured from inside the machine, actual conditions. Number two, the original bearing size is maintained. Yeah, we do need to get the fiber out, but we don't need any additional space in the housing. And when it comes to getting the fiber out, as you've seen in our experience slide, we've done so many applications that we know how to get the fiber out, and we will be able to support you in that challenge. Number three, stiffness and life of the bearing is unchanged compared to the base bearing. So we don't compromise on the function of the bearing. Number four, immune to electromagnetic interference. And this is simply due to the fact that our sensor is based on light. It uses light. So electromagnetic interference does not affect our measurements. So it's immune. Number five, it is free from measurement drift. This is because it utilizes an AC signal. It's a bit of a technical story, but many electronics-based sensors, they drift over time. Not our solution. It is very stable and robust. Then finally, number six, our technology can be applied to any SKF rolling element bearing. Doesn't matter large or small, any SKF bearing we can instrument with this technology. So as we close, I want to leave you with this. SKF Insight is not just a new product. It's a platform for innovation and long-term collaboration. Our technology has already proven itself in some of the most demanding environments, and we want to partner with you to push the performance and reliability of data centers to the next level. So thank you for listening in. And with this, I hand the word back to you, Jeff.
Mark, thank you. We know this is a pivotal moment. AI, along with the infrastructure needed to support and grow it, demands innovation and collaboration. We're excited to take the journey with you to help you improve applications, push technical limits, and deliver on the promise of a new age of intelligence. Let's get the conversation going and work to meet the challenges. SKF has the experience, the solutions, and has made the investments to support your efforts. Together, we can fight friction to move the world forward. Thank you for taking the time to be with us. We're looking forward to building the future with you.